Okay, welcome back everyone to another one of these tutorial videos on the theory of computation. So in this video, we'll be looking at a language classification exercise where we want to know whether the following language is regular, if it's not regular but context-free, or if it's not context-free at all. So if we look at this language L here, where we have a sequence of A's and B's, where we have sort of this constraint that the number of A's must equal the number of B's, then I think it's hard to imagine how a DFA could kind of enforce this constraint of inequality of A's, since it already can't do that of A's and B's, since it already can't do that for A and Bn. So we're going to argue that it's not regular. I mean, we could argue this directly via the pumping lemma. So, you could pick something like AP, BP, AP, BP, because, the sum of the A's is 2P, sum of the B's is 2P. Clearly, if you pump up, then you'll have more A's than B's. So this is one way. The other faster way would be to just say, well, suppose it is regular, then intersect it with B star, A star. Then it must be that, the B and the A that get instantiated, so they must be this B and this A, right? Why is it this B? Because um, if you start with B and you end with A's, yeah, it can't be that you start with this B and then you end with nothing, because then you wouldn't have this equality. And then it can't be that there's no B's and you just have A's, because then you won't have the equality again. So it must be that it's uh, this middle part. And if it's this middle part, then, the I is 0, this is 0, and then this is 0. So you have J is equal to L. So really, this is the language BN AN, which we already know is not regular, right? So that is a quick argument for why this is not a regular language. However, this is going to be context-free, right? And the way that we're going to be able to see this is by using a stack argument. So I'm not going to give the full PDA, but I'm going to give you the stack argument, and I'll leave it to you to try to implement it. So I have AI, BJ, AL, BK, where I plus L is equal to J plus K. So really what the stack is going to do is the stack is going to implement I plus L minus J plus K, right? So this is going to be fairly similar to the stack argument of the number of A's equals the number of B's, where you make a stack that represents the number of A's minus the number of B's. So if you're not familiar with the argument, essentially what we're going to do in this case is we're just going to say, for the first few A's that we're going to see, so suppose I see, 3 A's, I'm going to push an X for every A I see. So that's going to be the state of my stack. Once I see B's, maybe I see 4 B's, I'm going to pop for every one, so I'm decrementing my counter. At some point, I'm going to sort of run out, and that's when I'm going to switch to using Y's. Y's are going to kind of represent the negative side of this. So there's going to have maybe 1 Y. Then maybe I have, let's see, 2 more A's. So I'm going to pop this Y, seeing this A. Then I'm going to see this A, my stack is empty, so I'm incrementing back up. So I'll go back up to X. And then let's see, I need a single B here for it to be accepted. So if I have a single B, then I'll pop it. Reading it, I'll pop this X and I'll get an empty stack. If I have any more B's, then I'll add additional Y's. If I didn't have a B here, then I would stay with just an X. So that tells me that the accepting condition should be when my stack is back to being empty. So when the stack is empty, this implies, based on sort of the logic that I've sort of created, this implies that the number of A's that I've seen is equal to the number of B's. And, if I sort of create the logic, if I sort of implement the pattern of A's, B's within the state transition diagram, then I get the language that I'm looking for, namely AI, BJ, A, L, BK, where I plus L is equal to J plus K. Okay, so I leave it to you to actually think of the state transition diagram for this guy. The other way actually that you could have maybe argued this is you could have shown, so another argument is you could have first shown that this language is context free. So this is context free. So maybe you've already done this in class, and so you can just take this for granted. And then you say, well, I know that context-free languages are closed under regular intersection. So context-free languages are closed under regular intersection. Right? And so then if I take L and I intersect it with A star, B star, A star, B star, why is this regular? Well, here's the regular expression that denotes it. Then, I must have that the number of A's is equal to the number of B's because I'm intersecting with L, which is this. So then I get, A, I, B, J, A, L, B, K, such that I plus L is equal to J plus K is context free. So this is the other way that you could have argued this. Okay, so that's another one of these videos for language classification. Thanks so much for stopping by and see you in the next.